Hi, this is Mrs. Cahill with your Notes 3.1, Graphing Relationships. Most of these notes you're about to take on a note-taking guide that I've prepared. But for this first problem that's on your bell work, you'll want to put this directly into your notebook. Be sure to include the heading, Notes 3.1, Graphing Relationships, copy the description, and make the graph. So pause the video and do those things first. Okay, assuming you've got all of this into your notebook, let's read the problem. At the start of a snowstorm, it snowed 2 inches an hour for 2 hours. Then it slowed to 1 inch an hour for an additional hour before stopping. 3 hours after the snow stopped, it began to melt at 1/2 an inch an hour for 2 hours. So we need to graph that. What would actually help is to determine after each time frame how much snow there is so we can put some points down. Of course, at the beginning of time, we don't have any snow. Then it started to snow 2 inches an hour for 2 hours. Wouldn't that mean we would have 4 inches of snow after 2 hours? So if we head to 2 hours, we should be at 4 inches of snow right here. And we could connect those two. That line indicates 2 inches of snow per hour for 2 hours. Then it snowed 1 inch per hour for an additional hour. So that's only 1 more inch, and it gets us to hour 3, and we will then have a total of 5 inches of snow. And you can see that's less steep. 3 hours after the snow stopped. That means I need to show the snow not increasing for 3 hours. From 3 hours to 6 hours, we have no increase. We are level. And then it starts to melt after those 3 hours at 1/2 an inch per hour for 2 hours. So that gets us from 6 to hour 8, but we're only going down 1/2 an inch per hour. That's 2 hours. So we'll go down a full inch, but slowly. Now mine isn't to scale. I could make that look a bit neater, but here's what we're going for. The first 2 hours are pretty steep. Then we level off to less steep, not flat. Then we get no snow at all, so we keep it all. And then it starts to melt, but slowly. And hopefully you'd be able to graph something like that. Okay, now we're on to your note-taking guide. On number 1, we're asked to identify the following on this graph. By the way, in case you care, this graph is a parabola, and because the shape goes to the end of the coordinate plane, that implies it goes on forever. So we're going to identify the following, the x-intercepts. Well, I see them on my graph. They're blue. They're those two parts. They're where we cross the x-axis, and that happens at these values that they actually already have on the graph for us at -1, 0 and 3, 0. The y-intercepts, so where we intersect the y-axis, that's happening up here at 6. But as an ordered pair, it's 0, 6. The relative maximum. So the maximum of this graph. Sometimes graphs have more than one maximum. This one only has one. It happens right there. How would you read that ordered pair? It looks like it's at 1, 8. Relative minimum, this one doesn't have one because it keeps going forever in this direction. There is no minimum, so none. Intervals of increasing. Where is the graph going up? Well, let me erase a few things. The way you read this is the way you read in English, is from left to right. So as I read from left to right, then I would notice the graph increases where I have the red. And that happens, well, is that starting at -2? I believe I have the wrong digits, but I'll fix them in a second. It looks like the increasing happens, well, it goes on for infinity this way, but the increasing ends when I get to 1. But it was going on forever down here. So basically, anything less than 1 is where I have an increase. Oh, and I do have that backwards. I'm going to pause and fix that. So that should read that x is less than 1. In this range, from here all the way to here, my graph is increasing. So it happens at 1 and everything less, I have an increase. So where do the decreases happen? They start here. From here to here, we're decreasing. The decreasing goes on and forever in this direction down here, but it started at 1. At 1 and everything bigger. So I probably have this one backwards as well, and I'll fix it. No, that one's facing the right way. X is greater than 1 is where I have my decrease. All right, number 2, identify the same things but on this graph. The x-intercepts, hopefully you can see those just fine. We intercept the x-axis right there at 2 and 4, but as ordered pairs, they are 2, 0 and 4, 0. The y-intercept happening up here at 4, but I won't call it 4. That's the ordered pair 0, 4. Relative maximum, well, this one doesn't have a maximum. It goes up forever, but it does have a minimum. No maximum. The minimum is happening down here. What is that ordered pair? Should say 3, negative 2. Okay, where is the graph increasing? The increase, where we go up, as we read from left to right, the increasing happens here. Doesn't that start at 3? And it goes on to infinity. So at 3 and bigger. Where's the decreasing? Well, as we read from left to right, the decreasing happens there. And that's at 3 and anything smaller than 3. Okay, number 3. The following shows the elevation of a plane in kilometers based on the time after takeoff in hours. Answer the following questions regarding the function shown. A. Interpret the meaning of the 2 x-intercepts within the context of the scenario. So remember, this is a plane, right? Looks like the plane took off and is increasing in altitude. It levels off for a bit. Then it increases altitude again. And then it stays at that height for a while. And then it comes down for landing, right? So my x-intercepts are happening here and here. So what are those cases? Well, that's when my elevation is at 0, and that happens at takeoff and at landing. We're on the ground, takeoff and landing. B, interpret the point 5:15. That is this point right here. And what's going on there? Well, that's the point when we reached our maximum height. We're going to level off after that. We never go higher again. So that's the time when the plane reaches its maximum altitude. Number 4, domain and range. Your domain, those are all your x values, all the possible x values. And the range, therefore, would be all the possible y values. Number 5, there's nothing for you to do here. I need you to be with me as we talk about the difference between a discrete graph and a continuous graph. Notice you'll have a number 5. You have one below the other, but compare with me on my screen versus your paper. If a graph is discrete, it's countable. But if it's continuous, it's infinite. So what does that mean? Well, if it's countable, there's nothing in between, like the numbers 1, 2, 3, 4. There's no fractional amounts in between. But continuous would always have something in between. There's 1.1 and 1.2 and 1.3, and even numbers between those numbers. So we can't have a fractional amount if it's discrete, but we can have a fractional amount if the graph is continuous. Let's talk about some examples. For discrete, a good example would be markers. You can have 1 or 2 markers, but you can't have 1.5 markers. But with a continuous graph, time is a great example of something continuous. You can have half a second, a quarter of a second. You can have any amount of time you want. You can break it down into all the little infinite parts in between. Let's look at more examples. For discrete, number of basketballs in the school. A half a basketball isn't a basketball. We can only have whole numbers. But continuous would be your distance from home. You could be a mile from home, you could be half a mile from home, a quarter of a mile, you could be one step away from home. For discrete, a good example would be the number of students in the classroom. For continuous, time is continuous. For discrete, another example would be the number of websites you search a day. You can't surf half a website. If you looked at it, it counts. Weight is continuous because you can weigh, I can hand you a penny and you suddenly weigh a little bit more. I could hand you a grain of sand and you weigh a little bit more. Okay, so this is what the graphs look like. For instance, if I were selling lemonade, I can't sell half a cup of lemonade, but for every cup I make some profit. And there's no dots in between those dots. Those dots continue on, but it's discrete because there's no dots in between the dots. I can't sell half a cup of lemonade. But at the other graph, when we're looking at continuous, when we're comparing time and distance, suppose I'm heading away from home. As time goes on, I travel more distance and I can have different amounts in between. And so it's filled in with a line. It also can continue on. That's not why it's continuous, because this one can continue on. It's the fact that there are dots in between the dots. All right, number 6. Let's look at these two graphs one at a time, and we'll decide if they're discrete or they're continuous. And we're also going to list the domain and the range. First, that first one, it does continue on, but that's not continuous. It's discrete because there aren't dots between the dots. If your book is overdue, if you've made it to 2 days, you know, they don't give you a different fee for 2.5 days. That puts you at 3 days. There's only whole numbers. What is the domain of this? Well, we said domain is all the x values. I see the x values where I have numbers at 1 and 2 and 3 and 4 and 5 and 6 and 7. And I think that's my domain. Oh, I forgot 0. Okay, that's the domain. It's the x values. The range, we look at the y values. So we also start at 0, and then we go to, that looks just below 1. That could be 75 cents. If I were 2 days late, looks like I'm at $1.50, 1.5, right? Over here, it looks like I'm at 2.25. Ooh, there's a whole number, 3. And that's the range as I read it. It's the y values of those dots. All right, let's look at the next one. Temperature of heated water. So we have to realize that as I heat water over time, so time of heating water, my temperature goes up, but not in individual dots, but little amounts in between, little temperatures in between. That makes this continuous. So now the domain. I start here, I end here. How do I represent every number in between 0 and 5? Because that's what x is. It's in between 0 and 5. So literally between 0 and 5. So the range, we'll now be talking about our y values. We go from here to here. Isn't that in between 50 and 100? On a continuous graph, you'll always give a compound inequality for your answer. On a discrete graph, we typically give the actual values from the graph, the ordered pairs. Number 7, for each situation, tell whether the graph would be continuous or discrete. So the number of cans collected for recycling, really we can't have half a can, it wouldn't count. So that would be discrete. Number 4, pouring a glass of milk. Well, I could add 1 drop more. I could add the teeniest fractional amounts more. That makes it continuous. The distance a car travels from the garage, I could go a mile, but I could go an inch or anything in between. That makes it continuous. And number 6, the number of people in a restaurant. Can't have half a person. That'd be kind of gross. So that is discrete. Number 8, the graph shows the amount of rainfall during one storm. What does segment D represent? So read your graph. We've got time in hours. We've got rainfall in inches. Does kind of look like our rain's increasing. Oh, it increases like crazy. And then it levels off. What does that mean, though? What literally has happened with the rain? It got to its maximum right here. Did it get any higher? And if it didn't get higher, doesn't that mean that the rain stopped? We've received all the rain we're going to get, and it stopped. Anything to that effect is a good answer. Which segment has the heaviest rain? Well, do you agree that, yeah, we're increasing, ooh, but now we're increasing less? And this is where we increase the most, and that is the area indicated by C. If I erase, you can see it better. That's coming down like crazy. Number 9, Jason takes a shower, but the drain in the shower isn't working properly. Which graph represents the situation? So take a minute, guys, to check graph A, B, and C, and let me know which one that is. Well, A and B are kind of similar. They both go up and come back down. But think about it. Water in a shower, does it go up in individual amounts? No, it goes up continually. And the water's building up while he takes the shower, and then he gets out of the shower, and it gradually goes away because the drain wasn't working properly. This one is B. It needs to be continuous because water comes out of the faucet or the shower continually. What's wrong with this one is the water, this looks more like a bath, like he filled up the tub and it stayed with water in it the whole time. It wouldn't be that one. It is choice B. So that means we're not using these other two graphs. Now let's answer the rest. What kind of graph is it? Well, we kind of already discussed it. It's continuous. The domain, so remember those are your x values. X goes from 0 to 8 and everything in between. Write that as a compound inequality with x in the middle, the small number being 0, the big number being 8. X is between. And now the range. So those are my y values. How high does this graph go? Did it go to 3 or did it go to 2? You can tell better on your paper than I can. It looks like it went to 2. Started at 0, went to 2. Went as high as 2. Okay. And number 10, this I believe is your last question. A local salesman is going door to door trying to sell vacuums. For every vacuum he sells, he makes $20. He can sell a maximum of 10 vacuums a day. And we've got to make a sketch. Well, we could write an equation. Y equals, Y being our profit, $20 per vacuum. But here's my question. When I go to choose my domain, can I choose fractional amounts? Can we have half a vacuum? No, of course not. So we need to choose whole numbers like 0, 1, 2, 3. When I don't sell any vacuums, I make no money. When I sell one vacuum, I make $20. 2 vacuums, 40, 3, 60, and so on. But I have to stop when I get to 10 because that is the max. So is this discrete or continuous? Well, it's discrete because you can't sell half a vacuum. Now let's talk about the domain. The domain would be all of our x values. Well, didn't we talk about selling 0 and then 1 and then 2 and then 3 and so on? So you could write it like that. It's every number of vacuums he could sell. When he sells 0, he makes 0. When he sells 1, he makes 20. 2 makes 40, and so on. And sometimes you can abbreviate those answers. If you write your domain and your range this way, you could substitute this for your domain if you don't have enough room. If I write it like that, 0, 1, 2, 3, dot, 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 10, that implies I'm counting whole numbers and stopping at 10. And then I'd be allowed to do the same thing for the range. It's just a little bit of an abbreviated answer. So your work now that you're done taking your notes is not on Get More Math. It's going to be a PDF, lesson 3.1, and it's in Google Classroom. You're going to put your work on loose leaf paper. You're going to be neat and organized. And you're going to remember to label your paper with your name, date, and period so that we can collect it and take it for a grade.